Now, as it turns out, it's not as straightforward to eliminate weakly dominated strategy as it is for strictly dominated strategies. It doesn't work as well. And here's a simple example to illustrate this. In this example, both U and M are weakly dominated by D. So both U and M are weakly dominated, and you can verify this simply by observing that the payoff for strategy D is equal to the payoff for strategy M if player 2 plays L, but here if player 2 plays R, the payoff is greater, right? 4 is greater than 3, so there's simply weak dominance. And similarly, if you compare strategy U and D, you find that the payoff for strategy D is greater than the payoff for U here, but then 4 is equal to 4. Now, the order of deletion or the order of elimination is actually relevant and will determine different outcomes for the game. So if I first eliminate, if I delete M, for instance, I find that player 2 has a weakly dominated strategy R, right? 0 is less than 1, but 4 is the same as 4. So R is weakly dominated, and let's eliminate R. Now we can say that player 1 will play D because 6 is greater than 5. So the outcome of the game is for player 1 to play D and player 2 to play L. Now let's try a different order of deletion. What happens if you delete U first rather than M? Well, player 2 now has a weakly dominated strategy, but it's no longer R, it's strategy L. And you can see this because 0 is less than 1, 4 is the same as 4. So L is weakly dominated. So let's eliminate L. And now the outcome of the game is different. Player 1 will play D, strategy D, because 4 is greater than 3. So the outcome of the game is for player 1 to play D and player 2 to play R. Different outcomes of the game depending on the order of deletion of weakly dominated strategies. So that's a problem.